You know, in the world of electronics, you've got these two little components that look so much alike you'd swear they were twins, but swapping them can be an absolute recipe for disaster. I'm talking about the Zener diode and the TVS diode. So let's get into exactly why mixing them up is the difference between a perfectly happy circuit and a little cloud of smoke.
And that's the million-dollar question, isn't it? Because on the surface, they really do seem like they do the same job. They're both built on a similar principle, but trust me, their specialized roles make them about as swappable as a house cat and a tiger. Getting this one little detail wrong is the difference between a project that works and that dreaded magic puff of smoke.
The confusion, well, it starts right here with their symbols on a schematic. I mean, look at them. They're nearly identical. And they both work using this principle called reverse breakdown. All that really means is that they let current flow backward once a specific voltage is hit. And that one shared feature, well, that's the root of the whole mix-up.
Okay, to really wrap our heads around this, we need to meet our first specialist. I want you to think of the Zener diode as a world-class marathon runner. This component, it is not built for sudden explosive sprints. Nope, it's designed for the long haul. We're talking steady, precise, continuous work day in and day out. Its entire identity is built on just being consistent and having that endurance.
And that brings us to the Zener's one and only mission, voltage regulation. It's like a steady pillar inside your circuit, and its job is to guarantee a rock-solid, specific voltage. It's actually designed to live in that breakdown state constantly, just holding the line, keeping that voltage perfectly steady.
So let's break down its key attributes, right? First, endurance. It's built for that continuous, always-on operation. Second, you've got incredible precision, locking in that very specific Zener voltage, or VZ. And finally, it's a low-power device. It's meant to handle small, steady currents, not massive surges. You're going to want to remember that last point. All right, let's put our marathon runner on the bench for a second and meet the other specialist, the transient voltage suppressor, or TVS diode. Now, if the Zener is a marathon runner, the TVS is an elite bodyguard. This component couldn't care less about long-term, steady work. It is all about explosive speed and just raw, overwhelming power. It's designed for one thing and one thing only, reacting to sudden, violent threats. So, the bodyguard's job? It's pure protection. It just sits there, completely dormant, basically invisible to the circuit, until a dangerous voltage spike, like a jolt of static electricity, hits. And then, bam, it springs into action instantly, absorbing all that dangerous energy to protect everything else down the line. And its key attributes are built for exactly this mission. First, speed. And we're not talking microseconds here, we're talking picoseconds. That's 1,000 times faster. Second, power. It's designed to handle massive, violent surges in the kilowatt range. Its whole purpose is to clamp that voltage spike down below a safe level, keeping all the sensitive little components totally unharmed. Okay, so it's time to put our two specialists in the ring, side by side. This is where you're going to see exactly why you can never, ever swap them.
Let's start with response speed. A Zener is fast. Yeah, it reacts in microseconds. But a TVS, it reacts in picoseconds. We're talking thousands of times faster. When you get hit by static discharge, that microsecond of hesitation from a Zener is more than enough time for a chip to get fried. And then there's power handling. A Zener handles watts. A TVS handles kilowatts. They are not even in the same league.
And this analogy just hits the nail on the head. You wouldn't ask a long-distance runner to step in front of a speeding semi-truck, right? So you shouldn't ask a Zener diode to stop a kilowatt-level power surge. The outcome in both cases is pretty predictable, and it's disastrous.
But listen up, because this right here, this is the single most important and dangerous difference of them all. When a Zener diode gets overpowered, it usually fails short. That means it basically becomes a simple wire, opening the floodgates and letting the entire surge pass right through it, destroying the very circuit it was supposed to protect. A TVS, on the other hand, is designed to fail open. It sacrifices itself. It acts like a fuse, blowing itself up to save the rest of the system. So, knowing all of that, how do we make the right choice? Well, it's actually pretty simple once you understand their core missions.
Here's the cheat sheet. It's this simple. If your goal is to regulate a voltage, to hold it perfectly steady for something like a power supply reference, you need the marathon runner. You choose the Zener. But if your goal is to protect against unpredictable, high-energy hits like static shock, you absolutely need the bodyguard. You have to choose the TVS.
Let's look at a real-world example from a device we all know and love. In an iPhone, the circuits for the physical buttons, the power and volume buttons, they use a TVS diode. Why? Because the biggest threat to those buttons is a static shock from your finger. They need instant, powerful protection.
Now in that same exact iPhone, take a look at the charging control circuit. Over there, they use a Zener diode. The goal isn't to stop some massive surge, it's to precisely regulate the voltage for the command signals that control how fast the phone charges. See? They need precision and stability, not brute force. Two different jobs, two different specialists.
So, as we wrap this whole thing up, the lesson becomes crystal clear, doesn't it? These two components were built for missions that are, quite literally, polar opposites.
And if there's just one thing you remember from all this, let it be this. Zener diodes are for control, that fine, precise, continuous voltage regulation. TVS diodes are for protection, raw, fast, overwhelming defense against surges. They are not interchangeable, and picking the right one is absolutely fundamental to the safety and reliability of your entire design.
Which kind of leaves us with a final thought, doesn't it? If two tiny components that look this similar can hold such a critical fundamental difference, what other invisible details in engineering represent that thin line between a project's ultimate success and its complete and total failure? It's definitely something to think about.